it's always been the case that he's a programmer by accident. I think he prefers to play his guitar. He's been on the PhoneGap team, wow, how long, man? Since the beginning, you ran?
Day one.
You ran?
Not day zero, day one.
Day zero, day one. You built at least 3 versions for Windows, because Microsoft released at least 3 versions of Windows for phones. There was Windows 7, there was Windows 7 Mobile, there was Windows 8 Mobile, and then there was Windows Universal. It's a good name. Call it Universal, which was the one that we were all supposed to switch to. Now I think we're going to jump into some nice.
Sound is working.
Give it up for Jesse.
Thank you. So yeah, my first part that I wanted to say is, like, why is this developer talking about music? I've actually been a musician a lot longer than I've been a programmer. Music actually and computers brought me to a love of programming. Originally it was programming music, and then I realized I was comfortable behind the computer for long periods of time, which led to a career. Not a rock star career, but I came close. I tried it for a while.
Oh my God, dude.
Yeah.
Top right?
That used to be me. This is me. This is me now.
That's amazing.
The guy with the hairy chest was a singer, because that's a prerequisite.
Wow.
So I'm going to talk about web audio, which is a really amazing technology that I think is sort of underused to date. So a lot of people are starting to discover it and all the things that it can do, but we're going to explore a little bit of it, and I'll guide you along some of the stuff that I've been looking at in the last 6 months or so. So the first thing you want to do is create an audio context. You still have to do this in a couple different ways because there's still some browser flux happening, but soon it'll just be window.audiocontext. And here's all you have to do to load a sound. So this is a sound that we're loading over the network, right? Which in a PhoneGap app is a local asset. So we're going to use XHR to load it. We're going to say its response type is array buffer, and then we're going to ask the audio context to decode it. All we have to do after we've done that to play this sound is create a buffer, an audio buffer source node, and we're going to put all that wave data into this buffer, and then we can just call start on the source. So this is the way that you handle loading sounds that are short. And I'm not going to go too far deep in this, but if you want to play a longer sound, you can also use the audio tag itself. So this is going to preload a file. So I've specified a source for that file. And typically, this will buffer for some time. It'll be ready. And we can just create a media element source using that node. And then we can just call play. So I'll quickly demo the two cases here. So the first one, we're loading a sound, and we play it. Is that coming out there?
Turn it up a bit, or maybe lean your mic in.
Yeah, I don't know if that makes me louder too, or just sound. And the other case is using the audio tag. So this is actually an MP3 that's loaded, and now we're playing it. So you get the gist of that. That's Phil's favorite song, because that used to be what we used to test the sound API in PhoneGap in the plugin. And so every time that anyone ran the test, that song would start playing in the background somewhere, and I wrote it. So I'm expecting some royalties at some point. I don't know, we'll see. So there's a bunch of different ways to create these audio sources, right? We've seen how we take an actual audio file and turn it into something that we can play. But there's this. There's also using oscillators. And oscillators are where things get really cool. So an oscillator is something that produces a waveform, which is actually a sound, which in old analog terms gets sent to a speaker, which causes the speaker to vibrate. And this is where all synth sounds come from, essentially. So another way that we can create audio elements is from video. So video or audio. And also media streams, which isn't available everywhere, unfortunately. It's not quite there for mobile. But this is capturing sound from the microphone or the camera. And then once you have it in Web Audio API, you can actually manipulate it. So you can apply effects. You can record it. You can make VU graphs that show how much input there is. All the things we used to do in Flash, we can actually now do in JavaScript. So file formats, there's still a little bit that you have to be aware of. But if you try to work with uncompressed for short sounds, you're going to have a much better performance. And then if you want to play MP3s or MP4s, then you can do that as well for your longer sounds. So you get some compression as well. So one of the first things that you have to, if you actually want to dig into making an instrument or something beyond just playing sounds, you need to actually keep track of time. You need to quantize input so that it happens on beats and things like that. So you want to always be responsive. You want to avoid set interval. And the API provides some really neat ways that you can schedule sound to happen in the future. So I got a demo coming up. We talked, or Alex talked before about request animation frame. This is like the safest way to get it in the entire world, falling back to a set timeout. So once we have that animation frame, oh, okay, I'm going to go back to a demo, but I can just show you some of the timing stuff. Okay, so this is an app that I wrote that's been live in the store for 5 years or so. I've made like $400, I think, with various monetization strategies. Your performance may vary, but I was never in it to make money. So it's a visual metronome was my concept here. And what I wanted to do was provide a metronome that you could just look at and not necessarily listen to. So in music, if you're in an orchestra, a conductor will be going like this. So you can, as a group, you can see the time happening. And this is your downbeat 1, so 1, 2, 3, 4. So this emulates that by providing a nice animation. Then we can increase the tempo. I got a bit of a layout issue. I'm in between versions right now. And we also have this sound. So I've loaded 2 sounds. They're both in buffers. They've been decoded. And then I'm doing a bunch of timing to determine, has another beat occurred? If so, then play the sound. Otherwise, just wait. So it was key to have the animations, which are all in SVG using Raphael. Have this all happen in sync. So I spent a lot of time to get that to work. But this is all on GitHub if you want to have a look and play around with it. Also, this pattern is I am the conductor, but if you're watching the conductor, then you're going to want it to go the other way. So I'm going pretty quickly through these. I don't have a lot of time to talk, and I'm trying not to go into too much depth. I mainly want to get you excited about what you can do. And of course, all my code is available. You can look at it. All these demos are available on GitHub. So you can dive in, you can contribute if you want to, and you can see how all of this works. So that's avoiding set timeout with request animation frame, which is a high-res timer, and it is more guaranteed to fire than set timeout. And next, if you're digging into it, we've got rhythm figured out somewhat. So now we've got to figure out pitch. So for pitch, we have to do some math. In this example, we're loading one note that we're going to use for all of the different notes of a piano or a guitar or whatever instrument we're playing, right? So we use this magic little math here based on the fact that the pitch 440 is what's considered a concert A, and then we can calculate all the other notes, and we're doing this based on MIDI note numbers. So 69 is the note A. The Nazis and chakras, I'll provide a link at the end, but in a nutshell, there's some contention about whether 440 is the best A or 432. 432 would be good because 108 is a magic number, and 432 is 4 of those. But it's hertz, which is seconds, which is a human construct. So yeah, but it's a good afternoon read. And the number 440 was chosen by the Nazis because it's awful sounding. Is if you read the article, it's crazy. So I'll show you another quick demo. Where did it go? Okay, this is also in the store. I'm using a simple web server. I'm running all of this stuff in browser just because it's really fast, but everything I've shown you so far works perfectly across all Cordova supported platforms. So this is another app that's available in the App Store for free. It's a chord dictionary for guitar players, right? So we've got all the chords, and we can choose an E sus7, and this is again Raphael. So we've rendered a guitar chord chart, and we can actually play using that same math that I showed you to transpose one note to all of these. And we also we can strum it, we can change chords. You'll notice, though, that I'm using the note A, which is like where this X would be on a guitar. Once we get really high, we've actually transposed that note a lot. It starts to degrade. It starts to not actually sound like a guitar would sound. Right? You can hear the difference in like this note rings out for a long time, but since we've transposed it higher, when we get up to this note, it's actually very short. So a way around that is to have multiple ranges that you sample. So instead of using one note for the whole fretboard, you might use one for each string. Pull requests accepted.
So that would be 6 different MP3 files or WAV files?
Yep. You could potentially do a lot more. If you go to like a drum programming, like a real drum library, they'll sample each drum, and they'll sample it from a very light hit all the way up to a hard hit, and they'll do multiple of each, because if you chain drum hits really closely together, you get what's called a machine gun effect, where it's just each one is cutting the next one off, and it doesn't sound natural. But yeah, there's libraries out there that are just full of pitches, like tons. So there is a module in my code that's the tune instrument that does a lot of the pitch transposition for you. So you give it a wave file, like the path to a wave file, it'll load it, and you give it a root key. So you're saying that this file is MIDI note 69, and it'll actually take MIDI notes so you can play a piano. I have a piano in here. This is all stuff that you can dig into too. So this is a piano that I implemented. If you want to have a look at how you create a piano in HTML. If I could hit that thing. So I have a key row, I have a bunch of white keys, all with note numbers attached to them. And then I have a black key row, and they're just using CSS to round the corners, make them white or black, and make them overlay each other. And I'm still playing a guitar sound with a piano keyboard. Okay. So on to talking about synths again, a little deeper this time. Synths are where it really gets exciting and crazy. These oscillators that you create, they're essentially producing an output which you can route through different audio nodes. Essentially, it's a large graph, and you can plug individual nodes into other nodes. So you can have a mixer node which takes 2 inputs, mixes them, and outputs 1. You can apply effects via a node. So it's essentially a graph that you can mix and match and put all these different nodes in. And there's a really good example site that someone has made which actually lets you see a lot of this. So you essentially drag a media element on, and you can wire the output of the media node into the compressor. And then it's going into an analyzer, which is looking at it and drawing the waveform. And then that is going to the destination, which in this case is the speakers. You can also, let's see. I haven't spent a ton of time with it, so I just recreate. So I'm going to delete that guy. I'm going to take his output and put him in here. So it's actually compressing all of that audio that's coming in. So you can get as crazy as you want with this graph of nodes. So it's pretty amazing all the things that you can do. And I'll just get rid of that ugly sound. Did it stop? Yeah, you can see even after the source stopped, the compressor still and the convolver reverb still had input going, and it was still processing, so it still produced sound for a while. So dynamics compression, channel splitting, channel merging, the analyzer node, which unfortunately isn't available on Safari as of yet, hopefully soon. One thing to be aware with a lot of these nodes is, especially the analyzer, I've noticed that if you don't own the asset, if you're downloading from some website, an audio file, you can't actually look at the data. You can play it, you can apply effects to it, but analyzer is somehow a security restriction. So does anyone know what an arpeggiator is? Well, if you've seen Stranger Things, then you've heard it. That do-do-do-do-do-do-do-do-do. So one of the things I wanted to try, and I spent a lot more time actually writing code than I did preparing a presentation, is I wanted to see if I could do that in JavaScript. So I have here, I have a arpeggiator here. So essentially, what I'm doing is when you enter a key, it actually locks that key, and I can toggle each key, right? So it's playing that note repeatedly, and if I do 2, it's going to play both, and that's what an arpeggiator does. Essentially, that's all an arpeggiator does, is it cycles through the keys that you have pressed. So you can actually start making music doing some of this stuff. And if we wanted to, actually, I have a high oscillator that you're hearing, and it's a sine wave. And I can also throw in a lower oscillator, so 2 oscillators playing the same note. And I can change that to be a sawtooth, and then this might get loud. A square on top, and then I can throw in a few more notes. And if I wanted to get to full, I have a panic button in case it's one out of sync. Okay, so we're almost at Stranger Things, but I had to actually add modes. This is something I did last night. So this is playing, whatever order you press the keys is how it's playing, but I can make it go up, which it was already doing. I can now make it go down, or if I want to be like Stranger Things, then it's going up and down. And I can, of course, I have a tempo slider here, so I can go, what do we want to do, wub wub? So, probably don't have time for questions. There's some links. I'm going to provide all my slides. I'll tweet all of this out so you can get a hold of it all. And for sure, if you want to know anything more, if you want to talk to me, I'd love to talk to you about web audio and all the things that you can do. I have great ideas for apps, too. And no time.
This is amazing.
Yeah.
Thank you.
Thanks, Jesse.
Thank you.